All right. So that's some high level information about HTML. But let's actually get into trying to process this HTML in Python. So we've been dealing with this web request exercise over many weeks, and we have some progress in there. So I'm going to bring up my in-class copy of the web request exercise. I've linked to it at the bottom. And if you'd like to follow along, you could always consult our in-class exercise. Today, we're going to be focusing on the HTML challenges, as I mentioned. So when we return to this exercise, we'll remember that I guess there were some JSON related challenges, and we did those. We fetched some JSON data from the internet using, I guess, the request library, the request package. All right. And there was some CSV data on the internet, and we processed it, I guess, using the pandas package. All right, cool. Now, when we deal with HTML data, I'll be introducing you to a new package called BeautifulSoup. And it will help us programmatically parse and try to make sense of the data, the HTML formatted data on any web page. So let's focus on these HTML challenges. And specifically, we could start focusing on challenge 6. So what is this challenge about? It's like, hey, here's an example HTML file. Can you loop through the favorite flavors and print each one? All right, so what is this talking about? Let's see. What's this example HTML file about? So I shared this file with you in Slack, and I'd love for you to download it. Once you download this file about lists, what we can now do is open it in the browser. So after you download these two files, we could just like click on them or right click and say open in the browser, and we'll see what this page looks like. So before we go trying to process this page in Python, let's just see how the page is structured. Remember, when we're working with JSON data, every data structure is going to be different depending on where we're getting the data from and what data we're requesting. And so every web page is structured differently as well. This web page happens to be structured, I guess, like the following. We'll put the code up on the left and the corresponding web page on the right. So I think I just adapted that link that we just saw with the unordered list and the ordered list. So here we see a page that has an ordered list, like a numbered list, and an unordered list, a bulleted list. Also, what you'll see here are various identifiers for the elements. So in HTML, one attribute that we could use to uniquely identify a certain element on the page is the ID. So here I've given this ordered list a unique identifier, and that will allow us to perhaps programmatically reference it in an easy way. There's also the ability for us to mark up our elements with class attributes, in which case we can say, hey, all of these elements belong to the same grouping or class. And that would allow us to programmatically select a number of elements at the same time. So anyway, what we will be looking for when we're trying to determine if a page is programmatically parsable is very helpful if it has certain attributes like IDs and classes that we can hook into and try to use in our process of identifying and referencing these elements. So here on the left, we see some HTML. I guess there's a top level heading and H1 tag. Okay, great. And there's also some H2 tags like favorite ice cream flavors. Okay, great. All right. So our goal here is to programmatically loop through this list of favorite flavors and print each one. So we'll have to figure out some way to like access this order list, and we will do that using the BeautifulSoup package. So the way that this process goes for scraping any website is it's twofold. First, we actually have to request the data and get the text, the HTML formatted as text. Remember, when we were getting JSON data, when we fetched that data, it was actually in text format until we transformed it using the JSON module. In this case, we'll make a request for the data, we'll get the text, but it's not in JSON format. So instead of using the JSON module to parse the response text, we'll now use the BeautifulSoup package. So I'll show you how to use this. So now we can focus on our web request exercise. And we're going to have to figure out how to parse this page. But first, let's just get the HTML text, the response text at this URL. So heads up, I have also just uploaded these HTML files to GitHub, and we can make a request for the HTML files through the internet. So this is what we already know how to do. This is a two-step process. First, we'll make a request and get the data. Second, we'll use BeautifulSoup to process it. Before, when we were working with JSON data, we used the request package and we said, hey, let's make a GET request for whatever contents are at this page. So we'll do the same thing here with this URL. All right, so import requests. And now how do we make this request for the data using the request package? Does anyone remember? If we consult the work we've already done when we were dealing with JSON data, we will see this familiar pattern that we'll do every time. Requests package will use its function that it provides, which is the GET function, to make an HTTP GET request to what URL? Okay, we pass in the URL. Okay, great. So let's do something like that here as well. There's some data on the internet that we want. Let's go make a request for it. So like response equals requests package dot get. And now we'll pass in this URL, which has this HTML file, I guess, on it. All right. Cool, we have this response object, and 200 status code means that it was successful. But where is this data? One of the properties of the response object has the text data we care about. Does anyone remember what that property is? How we could access the data? Yeah, it's the text property of the response that has all that good stuff that we want. And then when it was JSON, it looked like JSON data. What is it going to look like now? Let's see. Response.text. Whoa. Whoa, very messy, right? This doesn't appear like, it's just super messy. So that's why it's helpful for us to also like view the page in the browser and try to get a better sense of its structure before we start working with this data. But what we'll see is that we actually got the data, and that's half the battle. So again, we'll do make a request. And now we have the data, but this isn't in JSON format. If this data looked like JSON, we could use the JSON module like we did in previous class and just say, hey, JSON module, convert this weird looking text to some real Python dictionaries or lists or something like that. HTML data is more complicated. So now is when we'll use actually the BeautifulSoup package. Whenever you have some kind of HTML document as text, like we do here in our response.text property, we can pass this to the BeautifulSoup package, and it's going to give us some kind of new object that has supercharged capabilities in processing this content. So how do we do this? Let's consult the documentation about the Beautiful Soup package. So in today's agenda, you'll see at the bottom my notes about Beautiful Soup, as well as some documentation for the Beautiful Soup package. So this is a third-party package, and like any other third-party package, we'll have to consult the docs on how to work with it. Like, is there a quick start guide? What do we do? So I guess like if we had some kind of variable that has this HTML string in it, which we do have right now with our response text property, what do we do with that string? All right, it looks like all we need to do is these two lines of code right here. From BS4, import the Beautiful Soup class constructor. Use the Beautiful Soup class constructor, pass in the actual HTML text, store the result in a variable maybe called soup, and now that soup object is going to allow us to programmatically search the HTML document structure. So let's take this one step at a time. Let's see if we can implement this template, this boilerplate code that we find here in the Beautiful Soup docs. From BS4, import Beautiful Soup, and then initialize a new Beautiful Soup object. Let's try this out. All right, we have our response.text. That's great. It looks good. A little messy, but maybe we'll try to make some sense of it. All right, is BS4 installed? Let's take a look in Colab. Pip list. What packages are already installed? Is Beautiful Soup installed? I think it's BS4. Let's take a look. Beautiful Soup 4, I guess, is how it's installed. So, okay, great. This package is installed, so we can use it. We don't have to pip install this package separately. All right, great. Now, instead of having some kind of HTML doc that they had in the demo, we'll use the response text because it's that text which is the string representation of our page. All right. So what data type is this soup object? Okay, it's a Beautiful Soup object. So if we want to learn how to work with this object, we'll have to consult the docs, but I'll give you some pointers about the most common things that we'll do with this soup object to help us try to figure out and process and parse the page. If we didn't know what we could do with this soup object, what function in Python could we use to ask that question? Hey, what methods and properties does this object have? Any object, but in this case, the soup variable. There's a function that we've been using that's very helpful. And it tells us what methods and properties does some given object have. Anybody remember? The dir function. So if we've never worked with this Beautiful Soup data type before, let's just see what's possible with it, like dir, and we'll pass in the soup variable. What can we do? What methods and properties does this Beautiful Soup data type have? Whoa, lots of stuff. But it's these find related methods that I want to share with you. It looks like there's all these different methods that will help us find various parts of the page. So like find one element, find all elements. So it's these finder methods that we'll be using to pick apart just one part of the page that we care about. And when we do this, how do we find certain elements on the page? Like, we know when we inspected this page in the browser, we saw that there's some kind of OL object that we want to get. So what we'll do here is we will use the find method of the soup object. So we can say soup.find, and now there's certain parameters that will pass in here. Generally, the first parameter is the element. In this case, we want this OL element. This might be sufficient because there's only one OL element on this page. So when we go to try to find the first OL element, we will get the one we care about. But if there were many OL elements, we might have to specify a certain ID or class when we try to locate it. And there may be other like class or like ID equals my flavors. I just made this up. I'm not sure if this is how we do it. I'll have to consult the docs, but let's see. Our flavors list is what I'm going to call this. What does that look like? Our flavors list. This weird, beautiful soup object will help us find various elements on the page using find or find all. If we say find, it will give us the first instance of what it finds that matches our criteria. But otherwise, we could say find all, and it will give us all the matching elements that match our criteria. So is this going to work? Let's see. Yeah, so here what we're doing with the find method is the first parameter is what type of element we want to find. In this case, OL, ordered list. And optionally, if we need to further specify the specific element, there's ways to do that. We can just pass a class or an ID to help us reference that element on the page. Cool, so we just like picked apart just this list from all of this HTML. The beautiful soup package and the soup data type, the soup object, helped us like find just this part of the page. All right, but this data is still in like messy HTML format. What we want to do is like loop through these LI items, I think. So what we see here is that these LI list items, these LI elements, are nested inside of our ordered list. And so we could say that they're child elements of this ordered list. So once we have the ordered list, in this case, I called it flavors list, we can now search like the child, the children of just this element. So we could say like flavors equals flavors list dot find all LI. And so what this is going to do is it's going to say, hey, you know, this ordered list, the one that we found already, inside there are a number of list items. Let's get them all. Let's find them all. And now print, how many do we have? 3. Okay, great. Right now we're dealing with weird data types called beautiful soup tags. So like print, what data type is our flavors list? We'll see it is a tag element. So we'll have to learn how to work with that, which we'll do in a sec. It's not too hard. We'll just grab its text most often. And then we also have like this list of flavors. What data type is that? Also, I guess it's a results set, which is just like a list of tags, essentially. All right, anyway, now that we have identified these 3 flavors, we could like loop through them. For flavor in flavors, print flavor, what would that look like? Okay, here we're actually printing the HTML element itself. But we want just the text inside these LI elements. And so with any tag element, which each of these flavors are, like print, what data type is our flavor? It's a beautiful soup tag element. The most common property of this tag element that we'll be trying to reference is its text property. So sure, we could print the entire list item, but why don't we print its text? Cool. Now we're isolating just the text inside these list item elements So what you see that we did was very incrementally. We took it step by step and we finally arrived at like this list of flavors. So let me just share this with you in Slack as well. Okay. And so maybe if we wanted to do a mapping operation, we could say like clean flavors equals f.text for f in flavors. And then print our clean flavors. Cool. So now we really have a list of strings, and now this is like a clean Python structure. All right. Questions, thoughts about what we just did? Okay. Cool. So I think that was our objective here. There's also this other exercise which will have us parse a table, but I'll leave that for you to do for practice. What I'd like for us to do together is see if we can process all of the events at this Georgetown website. And that's how we'll end class. And if we end early, we'll just cut it early. So again, the process is like, one, what is the URL that has the site that we care about? We'll find it. Okay, great. Store it in a string. Step two, we're gonna have to make a request for the textual content of that site. And we know we can use the request package to do this. We get a response back. And then it's the responses text property that has the HTML formatted text, but how could we process it and make sense of it? We pass it through this BeautifulSoup class constructor, which gives us a soup object. And now, depending on the specific structure of the page, we might try to find and pick apart various specific parts of the page to match our objectives. So that's like the process. So now we're going to do this process again with challenge 9. All right. So before we go writing Python, let's inspect the contents of this page. So we can just view it in the browser. Georgetown.edu/events. There's also a link here. Let's take a look. Okay, this is a page. Looks a little cooler than that other page I showed you. This has some styles. It looks cool. I guess there's some kind of list of events here. And how many events are there listed right now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So our goal for this exercise is to programmatically arrive at a list of these events. And we'll hope that there's 10 of them. Shoot, how do we start? What about this page would we even be looking for when we're trying to process these events? Not all pages are structured in an organized way. So what we're about to do is an important step in the process. We're going to inspect the contents of this page and see if it might be able to be scraped. If there's some kind of organizational structure about the page, that will help us. So we can inspect any page in the browser by right-clicking and saying inspect or inspect element or something. Again, you can right-click anywhere on the page and say inspect. And this shows us the corresponding HTML structure of the page. So this helps us make sense of like, well, what parts of the page correspond with certain other HTML elements here. But whoa, look at all this HTML. It's maybe kind of intimidating. If we can maybe just focus on one small piece of it, maybe we can cut through some of all the intimidating content here. So our objective in this case is to get like a list of these events. So like, where is it in all this HTML that these events are actually being displayed? If we click on a specific part of the page and inspect, we should hopefully see the corresponding section of HTML on the right. So at some point, we'll try to find the HTML that corresponds with just a single event. Here, I think we found it. Looks like this section has all the events, and maybe we'll key into this section, but let's see if there's some element that represents just one event or each event. Okay, I think it's this one right here. Whatever this is, div class equals CC component container CC event teaser row. What? I guess this is some markup that the Georgetown webmaster put on the web page to make it look a certain way. But since this divider element has a certain markup to it, a certain class, that will allow us to laser focus on just this element or all related elements that have the same class. It looks like there is another such divider with the same class, and it represents the next event. Okay, so like here's one event. It's in a divider with a class of CC event teaser row, whatever that means. But then it looks like the next event is also in the next divider with the same class of CC event teaser row. And it looks like there are a number of events here, and they each have a class of CC event teaser row. Okay, with this in mind, now we're confident that maybe there's some kind of pattern here that will allow us to programmatically parse this page. And when we look for certain elements from this page, once we request it and get the data back and convert it into a BeautifulSoup object, I guess what we're going to be looking for is, let's find all div elements that have a class of CC event teaser row. So I'm just going to copy this CC event teaser row. Programming in Python, we inspected the contents of the page and we got a better sense of the structure of the data. We did this when we were looking at JSON data. Hey, is this a list? Is it a dictionary? What kind of keys does it have? And that helped us give us a sense of how to process that data. And we do the same thing here for HTML. Hey, are there certain classes or identifiers that help us identify certain parts of the data we care about? Okay, let's focus on those. All right, so let's fetch this data in Python. So here we have this events URL, and then something about the CC event teaser row we might want later. So how can we fetch this data and get it into a BeautifulSoup object? Volunteer to help us repeat the process that we did a few minutes ago. Here we have a different URL, but the process might be the same as what we just did. Yeah, we need to make a request. So like import requests, I'm listening. Yeah, so we'll make a HTTP GET request for some contents from some web page. Well, which one? This events URL. Okay, cool. And maybe just store the result in some kind of variable, either R or response or whatever. All right, cool. So let's do that. Cool, we have this response. Now, next step. Yeah, r.text, sure. We'll just check it out. What does this content look like? Whoa, look at all this stuff. Maybe it'll be, there's a method to the madness here eventually. Okay, I'm listening. Yep. After that, yeah. At the very most basic level, all we need to do is pass that response text in here. There might be a second property like HTML, blah, blah, blah. Let's see, what do we do? Like, do we need this this HTML dot parser? It might sometimes be helpful. Let's see. Do we need that? Let's try it without that. Do we have this like soup object? All right, so we have some kind of soup. Whoa, all this data here. Well, hello. Whoa, lots of stuff. All right, we have a beautiful soup object. I guess optionally we could also pass in that second parameter. It might not hurt, but I guess it's not required. Okay, cool. We have our beautiful soup. We have our soup object now. Cool. So that's half the battle. We have run our raw HTML text through this smart, beautiful soup class constructor to give us a soup object that represents the contents of the page. And now we could use the soup objects finder methods to help us find the content that we care about. So in this case, when we looked at the structure of the web page, we saw this event teaser row, I guess. So why don't we try to find all of the dividers that have a class of event teaser row? Something like that. So what we could do here is something like soup. We know the soup object has find or find all methods, and we'll just use find if we just want the first matching element, or find all if we want all of the matching elements that meet some kind of condition. So the parameters for the find or find all methods, the first one is what type of element we want. In this case, it's a div. And then the second one is normally just the class. So we can omit a parameter name here. If we omit a parameter name on the second parameter, it's going to assume that we're passing the class. Before we used an ID instead, but now we're going to use a class. So there's many elements that share the same class, and we want to find them all. And once we try to find them, how many are there? 10. All right, great. That's good. That's a good sign. When we looked in the page, we saw 10 of them. All right, so where do we go from here? We have this like list of listings. Why don't we just start working with the first one, just for practice? Like maybe like listing equals listings 0. I'm just using the word listing and variable like listing here. You could use whatever you want, like events maybe would be fine. Like maybe I'll say like event equals listing 0. I don't know. It's totally up to you. We could call this like events. I don't know. It doesn't matter. Events maybe. All right, there's 10 events, and let's just focus on the first one for now. So we'll access the first event from this list. What does this event look like? Okay, here we go. There's some parts of this. So let me just share this with you in Slack so you can be where we are. So now so for the events challenge, we'll do some stuff like this. Make a request for the events data. Then run it through BeautifulSoup. And now we can start finding the elements we care about. And sure, we could maybe like loop through these, but let's just look at the first one. Event 0. Whoa, look at all this stuff. All this HTML. Let's see if we can pick out the date and just print the date. Here we see it's in here somewhere. April 5th. We also see in here somewhere is this like title, this person's dissertation. So we want to try to assemble all this information about this event, the date, the title, the location, and time. And maybe we'll store all of this in a dictionary or something, and it will represent our event. So when we have this element in HTML format, I guess we'll have to now look for subcomponents or child elements that has the information we want. So if our first objective here is to pick out just the date from this event element, do you see any part of this HTML that might help us isolate just the date from it? This also may be easier to look at in the browser. We see it in both places. Like if we want to just isolate the date, here was our teaser row. And now there's like some subcomponents of this. It looks like this subcomponent is a divider with a class of fDate. Okay, cool. So why don't we try to pick that child element and just ask for its text. The way that we're going to do this is like this. Here in our event element, we see that there's a child div with a class of fDate. So let's look at this child element now and try to pick it apart in isolation. Hey, you know that event we were just working with? Can we find a div that has a class of fDate? All right, cool. Now we're isolating just this one part of the overall event structure. And we have just the date. Right now, this is the HTML version of this element. And so we could say like date tag equals this, and then print what data type is our date tag. And then we could also print the date tag. So we'll see that we're dealing with a BeautifulSoup tag data type. And the thing we'll do with this most often is just ask for its text. So here our date tag is an HTML element. It's a BeautifulSoup tag data type. And if we want just the April 5th here, the inner text, all we'll say is date tag.text. All right, we did it, but I guess there's some line breaks and spaces around this text. So what we'll do is we will take that text and invoke the string strip method on it, and that gets us a clean April 5th. So I'll share this again in Slack. If event is event 0, now we can find our date tag and eventually arrive at just the text of the date. So again, that progression was like this. Hey, our overall event element has a lot of subcomponents to it. Looks like the title's in here, the date, the location. We'll have to work on one of them at a time. Right now, we're focusing on the date. Is there a part of this that will help us identify just this date? Yeah, it looks like there's a divider with a class of fDate. All right, so we'll try to identify that first. And then we'll take its inner text and then we'll clean that up, basically. So sure, we'll find a subdivider with a class of fDate, maybe store it in its own variable. Now we have this entire element, but we just want the text of it. And that text might have some spaces or line breaks. And so we'll just strip away all that extra spaces and line breaks. And here is how we get our date. Cool. All right. So I know we're kind of We have 10 minutes left of class, so let's complete this together. Let's find the other parts of this event. Let's try to get the title. I would love a volunteer to help us figure out how to print the title. We see here the title, I guess, is inside this H3 element. So let me know if you have any thoughts on how we could grab the title from this H3 element in our event. So far in our event, we grabbed the date part of it. Check, we're done with this part. Now it looks like there's another part that has the title in it. So any thoughts about what we could do to just isolate this title? Since it's in an H3 tag, maybe we'll search for that. So before we said, hey, our event, find a sub element of a div that has a class of this, blah, blah, blah. But here we just want to find the first H3 inside. So what we'll say here is like title tag equals event.find. Now here we just want an H3 tag. Cool. So we picked out just the H3 tag in our event. There's still some more stuff in here. But we know every element has a text. So what is the text of this title tag? Okay. Dissertation defense. Looks like there might still be some characters on either side, so we can now strip this. Cool, we got the title. So we're picking apart just certain aspects, certain child elements here. And as you can imagine, we could do that for the remaining parts of this event. So we have a title tag. And we can grab its text and clean it up a little bit. Cool. So we are just working our way through this structure, one child element at a time. And this is like the process that we would do. And so just to put this all together, after we pick apart all of the parts of this event that we care about, including, I guess, let's see if we can get the location. There's a div with a class of F event location. We'll just repeat this process. Like, hey, can we use this event element and find a div that has a class of whatever, F event location? We'll grab the text and strip that. All right, Healy Hall. And let's see, what else in here could we grab? The time looks like it's in a time tag. So we'll just try that, I guess, like event, find a child time tag, I guess, and then take the text and clean it up. All right, 9 to 10 p.m. Cool. So anyway, hope that you start to see how we kind of dig into each specific part of this page one at a time. I think the other thing that we'll be able to do here is grab the URL. So like we'll grab this A tag and take its href attribute. So event, find an A tag, which is a link, and then take its href attribute. That will give us our URL. Cool. All right. So we've just kind of taken this one step at a time. We're like, hey, we know we have 10 events. And we know we want the information for each one of them, but why don't we try to get the information just for the first event first? Now we can extend this a little bit and loop through all these events. And so this is the last thing we'll do here together in class. We just practiced like working with one event, but why don't we loop through all the events and assemble some kind of list of clean events, which will be like a list of dictionaries. So we could say for event in events, since we already arrived at our events, I guess events, we said, find all the dividers that have a class of teaser row. So we have this list of 10 events. So now let's loop through them and treat each one as a variable called event. And now we could use some of this code that we've done, but instead of working on just the first event, we'll work on all these events. So we can assemble a clean version of this event, maybe as a dictionary, and then collect that for later. Here we're just using a mapping operation. So all these handy operations come into play, like mapping. Now we're going to assemble our own dictionary of this event. I think we want the title, the date, the time, the URL. I think that's it. Now we can just borrow some of the code that we identified from above, like how do we get the URL? Okay, we'll do this. How do we get the time? Okay, we'll do this. How do we get the date? That was above. What was it? Date tag, here it is. Event find div f date. Okay, cool. Date is this dot text dot strip, and the title was event find h3. All right, cool. Dot text dot strip. All right, so we're now putting all of this together in one loop, one mapping operation, and now we arrive at this clean list of event data, and that's where I'll drop the mic on this one. So I'll share this with you in Slack. And now we have this data in Python, and that opens up a lot of possibilities for us to do other things with it, like, oh, interface with the Google Calendar API and create an event on your calendar for each one of these events. We might have to further split the start time and end time, I guess, which we could do. If we wanted to store these in Google Calendar, for example, like, oops, hello. Start and end time. If we have this text as our time in general, how could we split it into start and end? Dot split on the basis of our dash character. And now that gets us the start and end time. So we could say start, comma, end equals this. Print start, print end. Cool. So we can further parse this data as desired as well. So maybe in our clean dictionary, we can break up that start and end as well. Start time and end time. All right. Anyway, that's just something practical that I saw we could do there to improve the process data we have. So now that we have the start and end time, now we can really make requests to like the Google Calendar API and create these events, for example. So what you see web scraping allows us to do is programmatically parse some kind of contents that we find on a web page. But again, It really depends on how organized the web page is and what elements does it have and how are those elements marked up. We observe the markup of the page, and if there's a method to the madness, then we could try to process it. And the process is similar to what we've been doing for other other formats of data, namely JSON. First, we make a request to that website that has the data. In this case, it's HTML page. And then now we've learned this new package called BeautifulSoup that helps us parse the HTML data in its nested structure. And then what we could most likely do is try to make sense of and clean up that messy HTML data, pick apart just the parts we want. And now we can work with this data in more detail.